Okay. Uh, what's up, everybody? Welcome back. Last time we had a great conversation about using the commercial software called NV to run classification tools in order to get a geological map from an image or a picture. And last time, when I was talking about when we were going over and talking about how it is done, I think at some point I promised that I will give you an example using QGIS. And there used to be a tool in QGIS that you can use to do the same job, but since those are supposed to be updated, so I think every time there's a new release, and when you have a new release, it's coming with a bunch of plus and minus. What I mean by that is you may have a tool today that is working in a specific way to do a specific job, and the update is supposed to be helping you in a way to kind of, do the same job in a better manner. Sometimes it's an update because the algorithm behind has been upgraded. Sometimes it's an update because of the way you have to handle the data that you bring into the algorithm. Sometimes it's an update just because you have changed so many things behind. And so there used to be a tool in QGIS that I would use to do the same job. And I recently found another tool that I use also for classification, but in a different manner. And that one is like when you have, for example, Landsat images, and then you make like a composite, like a RGB composite, maybe 321, and it gives you a support, and then on that support you can run classification. So today I will show you how to use that tool instead of the previous one where you will actually bring an image. And what we will do next, so it's good, I can use that tool just to explain, or maybe not explain, but maybe just give you an example of classification in QGIS, just so that you know you can do it using NV. If you have NV, good. If you don't and you have QGIS, you can always find a way to do the same job. So today I will show you how you can get those plugins and how you can actually use them. We will do something very simple, pretty straightforward, nothing complicated. Basically just bring into the plugin the different Landsat images that we want to use to run the classification, and I will use clustering technique instead of supervised classification, because if I do supervised classification I would have to build region of interest, and I don't want to spend too much time into this video because I just want to give you a short example. So yeah, let's just get right into it. So here we are. This is QGIS, and as I was saying, the main goal for today is just to show you how you can get this plugin. This is SCP, and I think maybe it's not, but I believe this is one of the latest version. And so first, you probably wonder how I managed to have this installed in my QGIS environment, because obviously when you install QGIS, it's not coming with these plugins, right? You need to go and first get them from the server. So it's very simple. You just have to go to plugins, manage and install plugins. I'm pretty sure if this is not your first time using QGIS, you know exactly what I'm talking about. But if this is your first time using QGIS, then this is where you will do it. You go to plugins and you hit the manage and install plugins, and over here you can just search, for example, well, you want to go to all, because this is where QGIS can go and read those packages, not only those that you have installed in your software, in your laptop or your computer, but those that are also available online on different servers. So you want to type, for example, something like classification, and you want to search So if you are connected, if you're online, when you type classification, hopefully I have the correct spelling. So if you type classification, you will have a list over here of different plugins that you can get, and you can download them if you want. And to download, it's very simple. You click on one plugin, and this uninstall is going to be installed instead, and you will install it. And once you have it installed, just remember the name. Like this one, for example, the name is SCP. You can see it here. And so now I know I have SCP installed because here we are. I have SCP right here. Another way is just to go, if it's a plugin, then most likely you have a tutorial of that plugin somewhere online. So go online and trying to get the tutorial to know exactly how it works, and how you can tell if you have it installed or not in your laptop. So that's the first step. So like I said, SCP is very good when you have like multispectral images. So you have the option of combining all those different images together to make a visualization of something specific. Could be that maybe you are interested in the changes over time caused by a specific factor. Maybe could be fire, wildfire, or domestic fires, or I don't know. Or it could be changes based on, I don't know, you can think of any specific applications that you want. Sometimes those multispectral images are good for accessing those type of problems. So here we're not talking about that. We're just talking about the plugin, which is this, and the way it works. So you want to have, I tried something here. I can show you. You want to have a composite. This one I made it using Landsat 5, and I think I am composing. So over here I have 3 bands. I think band 7, 3, and 2. I'm not going to tell you why I have those 3 bands, but there is a specific reason why you want to combine those 3. So you combine those 3 and you have this. Now the question is, how can I go from this to something where maybe I can separate between the yellow pixels, the kind of blue, and the gray to white pixels, let's say like that. And so easy to do with SCP. You will bring your band set here. So I think, yeah, a 7, 3, and 2, and you will create your virtual raster. Then you hit run, and it's created right here. This will be the same thing. Well, not exactly, it's reversed, but you see the point. So once you have it directly here, you can actually do a bunch of processing. I don't know if I want to go over all of that, but I can just talk about this one, for example, which is pretty straightforward. You set the number of classes. You remember what I was talking about when I made that example with NV, right? It's a little bit the same thing. It's not the same algorithm, of course. This is minimum distance. This is not the k-means. I don't think it's the k-means. That is not the k-means. Okay. So you define a number of classes. Oh yeah, wait, it's the k-means. I take that back. So yeah, it's the k-means. You define a number of classes. You define the threshold. You define the number of iterations. So it's basically the same thing. The band set here is something that will indicate the band set here. So if I have 2 band sets here, then each of them will have a specific ID. So if I want to process a specific band set, I just have to know what is the ID attributed to that band set over here, and then when I'm back here, I just have to say, okay, I'm working on band set 1 or I'm working on band set 2. If you are happy with the parameters, you hit the run button, and that's it. It's going to take some time, so I'm not going to hit that button. But basically, when you are done, you have something like this where you can actually see those different. So 1, 2, 3, 4. Okay, I had 4 classes, I think. Yeah, I think so. I think I was working with 4 classes, not. Yeah, I was working with 4. So you have those 4 classes, and so again, remember the idea is to bring a bunch of pixels together. So if you look at this and you look at this, what you see is it looks like I have one class for the yellow pixels in a way. I have another one for well, I see a bunch of green here, so looks like the green is more related to the gray and white pixels. I don't see too much of yellow like this one. I don't see too much of it though, because that will be I was hoping I can zoom in. Yeah, I don't see too much of it. So I mainly see just the yellow and I mostly see the yellow and gray to blue, gray to white pixels. This one is there, but it's not as much as the other one. Oh, you also have this one, so this is very interesting. So the dominant pixels are these two. So these 2 classes are dominant, and these 2 I don't really see them, which is interesting. But I think you get the point where it's like you basically can use this to. Oh, I see a bunch of yellow here. Okay, let me just go and zoom in. Looks like we have some. Oh yeah, well, very small, very small, but yeah, we have it there. So yeah, and so now you can tell why it's important sometimes to think about different methods, right? Because now this one I got it using the clustering technique, which is like an unsupervised classification, but maybe this is one of those situations when you want to use supervised classification. I will leave it up to you to decide if unsupervised or supervised is appropriate for this exercise. But basically, I just wanted to show you can do classification in QGIS using something like this. And in the beginning, I was talking about the different like we have different options. Not SCP is not the only plugin that you can use. There is a bunch of you have so many options out there actually. I think what I would do is next time, because this is something I also find interesting. A long time ago, I learned how to use this tool, which is coming when you install QGIS, especially on Windows. You have a tool coming with QGIS. I think it's called Sagagist, and no, you have Sagagist coming with QGIS, and you also have Grass. So these tools, they are coming with QGIS, and most of the time, I don't know if people are aware, but you can use those for things like this. Like if I want to do classification, Sagagist has a toolbox where I can actually run the k-means for clustering, or I can run some supervised classification techniques. I think Sagagist actually also has a decision tree, which is something very useful sometimes when you have like a rule to distinguish between pixels. Like, oh, maybe if the pixel value is between 0 and 1, then it is this type of object. If it's between 1 and 1.5, then it's this type of object. So in that case, decision tree can be a good option. So I think what I will do next is I will use Sagagist to just show you how it works. And why not? If I use decision tree in Sagagist, then after that, I will use decision tree in NV to kind of compare and see what is different between those two. I love QGIS because it's open source, so it's not something you would have to pay to have. But I also love NV because sometimes, how should I put it? With NV, sometimes it's really just a question of knowing where the toolbox is, and once you know it, it's just a few clicks and then you have the output. With QGIS, not so much. Sometimes it's really, because QGIS is like you do research, you have a tool and you want to share with the community, so you make it like a plugin. and you get in touch with the QGIS people, maybe they would have to test your plugin and see if it's good, if it's working and stuff like that. Then you would have to make a tutorial, then you put it there. But you will probably have this experience if you have worked with both like commercial software and open source, or like open project type of software. Most of the time the commercial version, they are pretty, so they want to reduce the amount of work that you will do to understand how to use the tool, and just want you to, in a very quick manner, short manner, but still efficient one, to get the result. And when you use something which is open source, sometimes it's not like that. Sometimes people who are developing open source software, they also want to include that component, but not always. An example is when someone is developing a Python package instead of a software, and he's developing it for his research in a specific way. Then you want to take that package and use it in your research, which is not, maybe not the same, maybe you're not talking about the same thing, it's not the same topic. Then you have to adjust the source code behind the package. This is when you realize it was, well, the tool is good, it's open source, but it's not that easy to use, because then you will have to change a little bit. But with commercial software, this is not something you do. They are usually developed so that you can have different people coming with different backgrounds, so different questions that they want to investigate, and they have data. And the thing that you're offering is a platform where, regardless of those differences, like regardless of the domain, regardless of the question, you can always bring in the data, process the data, and get the result. So yeah, that's why I usually like doing this comparison. So next time we will use Sagacious to run some classifications, most likely decision tree, and after that I will use NV, again decision tree, just to compare. It's really not like comparing and trying to see who's best, but comparing the experience of using both. See.